Okay, picking up where we left off on page 229, we're talking about the attributes. We're kind of zeroing in on this piece of this class example. And so the attributes, as I mentioned, are kind of the things that kind of uniquely identify that, you know, the nouns associated with the object itself. So these describe the object. And you can probably imagine that even though I might have two Mary Smiths in here, you know, it's very possible that there are two Mary Smith, age 25, and female, and have red hair in the world. It's possible. So even if their attributes are the same, when you compare the instances of a class, they're not the same. These things are completely unique. Okay, so there's some examples here that talk about, like on the fitness schedule example. But basically, you get the concept. I'm not going to dwell on it. Basically, the things that describe the object. On page 230, they zero in on the methods part. And the methods are, of course, the verbs, the things that you can do, like, you know, turn left for a car, or stop or slow down, or in this particular case, you know, read a bedtime story. So once again, you don't, at this level, you don't actually describe how you're going to read the bedtime story. You don't talk about, you know, go upstairs and sit on the edge of the bed because you might not have a two-story house. Or, you know, drive in the carpool. You might have different cars. Like, I would kind of expect you to have different cars. So the actual implementation details are not really relevant at this point. This is kind of a generic way of thinking that all parents have these particular attributes and do these particular things. Perhaps this is kind of a dumb example, but you get the point. So these are the verbs. And again, they may be, in their little diagram, they talk about, you know, breaking down into steps, boom, 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 boom. But we don't normally do that here. We don't normally get into how to read a bedtime story, as an example. Not at this diagram. Later on, you'll probably have to do that, but not at this point. Okay, so a message is essentially the external thing that comes in to this object to tell it to do the things that it knows how to do, right? So a car knows how to stop, how to slow down, but you have to tell it to do so. So in the example of a car, you step on the brake, which tells the car, oh, I have to do the slow car routine, so it slows the car. Do you actually understand how the car slows down? Do you know the inner workings of? No? Well, that's okay, isn't it, right? You don't have to be an auto mechanic or an automotive engineer to be able to drive a car, do you? You don't need to know the inner workings of how steering wheel makes the car turn, or how the accelerator makes it go speed up. That's not relevant, because they have defined an interface that is applicable to almost all cars. And once you know that interface, you can get up out of your Toyota and go to your Chevy, and you will not be lost. You won't think, oh, I don't know how to drive this. I mean, it may take you a couple seconds to find the windshield wiper or turn the lights on or something, but the steering wheel, the brakes, the accelerator, all those kind of things are going to be very, very familiar. That's the concept of object-oriented programming. You make these things so that the interfaces are well known and well understood, and therefore you could pull one of these objects out and replace it with another object, and the user will not be completely lost. I could swap out your car, and you won't have to go learn how to drive over again. Most likely, you'll be able to just jump in your new car and drive off. So, okay, that was a rant. I apologize. So, back to the topic at hand. Attributes and methods. So the messages is the way that you diagram these things to tell it to do what it already knows how to do. Got it. Okay. Sorry. Now, there is a kind of an interesting concept here on we're going to be talking about later, that if, let's say I have an instance of a class called pet, and one instance is a cat, and one instance is a dog, and my class says speak. And so I turn to my dog and say, speak, and the dog says, woof. And then I turn to the cat and say, speak, and the cat says, meow. Well, it sounds like speak and spell, doesn't it? I told it to do the same thing, but it did different things. And that's a concept that'll come up a little later in the chapter. But just because you have the exact same message, like speak, and the class has a single thing called, say hello or whatever would be appropriate for a dog or a cat. I guess the speak method. It doesn't necessarily mean they're going to do the exact same thing. Okay. So on page 232, they talk about the classes. And here's kind of what we're talking about, that a class can have subclasses. So this is a class of vehicle, and every vehicle has a make, model, year, blah, 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 blah. But cars might have slightly different set of attributes that you want to just tack on. And minivans might want to. For example, the minivan, you might want to include how many passengers, which really wouldn't be appropriate here. A truck, you might want to add an extra attribute like load limit, which wouldn't really be appropriate for a car or a minivan. And a school bus, you might want to throw in something like, how many emergency exits are there. So again, you start with a very generic thing, and you can just make subclasses, and the whole point of making a subclass is you could, instead of using a base class and have 4 subclasses, you could just create 4 separate classes, and they just happen to share the make, model, year, weight, and color. I mean, that part is unique, is the same among all of them, so you could just do it that way. The problem is, the more times you copy and paste from one chunk of code to another, the more likely you're gonna make a mistake. And so this way, you don't do any copying and pasting whatsoever, and the things that are common among all these are separated out. Trust me, this is a cool way of doing it. And again, this from a diagram perspective, there's a relationship that comes up, and we'll talk about relationships. It's called a is-a relationship. So a car is a vehicle. A minivan is a vehicle. A truck is a vehicle. A school bus is a vehicle. So this class-subclass relationship, you could say parent and child, or you could just say this is a subclass of, or a car is a vehicle. Okay. Whew. So again, let's get right on page 234. They actually go into the relationships. So relationships just kind of make it easy for these things to be put together. It's just less steps involved if you have these kind of relationships. There's the relationship called inheritance, which is what we're just talking about. And inheritance is just like a shortcut. Instead of having to build an entire class over again, I'll just take an existing class that somebody else has built, perhaps, and I'll just tweak it. So look at it from a programming perspective. Let's say that Bob has created this really cool print routine, and he spent 6 months on this print routine, and it's gorgeous, and I want to use it, but I can't use it exactly the way I need to tweak it a little bit. Well, I could just steal his entire source code and start over, or I could just say I'm just going to pick up where he left off, and I'm just going to tweak it a little bit. So I don't even have to look that much at his code. I can just say, well, I want my header to be over here. I want my page numbers to be over here rather than where he put the page numbers. So I just go in and just make some minor little tweaks because he wrote it as a class, and all I had to do was create a subclass which added a few tweaks to it the way that I wanted it. So the inheritance is really cool. Alrighty, and the is-a relationship. Okay, so they keep talking about the parent and child, but I think you guys can figure that out. The parent has the common set of attributes and the common set of methods. Child objects are allowed to inherit, just like from a genetic point of view. They inherit all of the common attributes, all the common methods, and they are allowed to tweak them. I mean, for example, I inherit the hair color of my parent. Well, I guess, but I'm also allowed to dye my hair, so I can go in and change that, that kind of a thing. They're also allowed to completely override an attribute or a method to have it do something completely different. Okay. On page 234, they talk about this object relationship diagram. So this is kind of what I was talking about. This top part of the diagram is the inheritance piece. A manager is an employee. Office staff is an employee. An instructor is an employee. So that's that part. And these other ones are not. These are still relationships, but they're relationships not based on inheritance. And you often use this relationship arrow typically is an action verb. So a manager determines the schedule. The office staff administers a record. The instructor teaches a class. A student takes a class. Those kind of things. So this has a combination of inheritance kind of rules and just normal relationship rules using action verbs as the arrows. Okay, so the whole point of this is to show how the objects react to each other and which ones have to do what. So for example, if I know that a student has to take a class, that means that this class has to have an interface that this student knows about. Well, what about employee? Does employee need to know about that interface? Well, no, of course not. So these interfaces are only the ones that are participating. So does the office manager care about how the registration record adds a student? No. So this shows me what student object needs to be able to do. It needs to be able to talk to the fitness class object. It needs to be able to talk to registration class. So this kind of helps you with defining those interfaces between the two. Okay, on page 235 they talk about the UML diagrams. And there's a gazillion UML diagrams, plural, or is it just one? So they start talking about, it uses a set of symbols to represent graphically the various components and relationships in a system. Yep, that's pretty straightforward. And the first one we're going to talk about is use case modeling. Use case typically this is very similar to the contextual diagram in a data flow, where it's high level and it talks about all the external entities on the outside talking to things in the middle. So it's kind of sort of similar to that. And then you can see little goofy little stick figures. And stick figure, even though it kind of looks like a human, doesn't necessarily have to be a human. They call them actors. And an actor could actually be another application. But hey, typically it's a pesky human being. Okay. So they have a little stick figure for an actor. They have little ovals for these objects or events, things that have to happen. So it says some examples there about a student, adds a fitness class and how this particular thing has to happen. The add student thing has to occur. So they have a stick figure showing, change availability, that kind of stuff. Okay, on page 236, they kind of talk about how you can have a use case documented. And they have a little table there, and it's pretty straightforward. They talk about the name and the action, description. If it was successful, what's going to happen? And if it's not successful, what's going to happen? And any preconditions, post-conditions, and those kinds of things. So that's a pretty cool thing, and also probably a good place to stop at the 15-minute mark. So we'll pick this up again in just a few.